Hello everyone, welcome to aptdemy. Myself Dr. Nandita, and today in this video we will solve a typical problem which has been taken from JEE Advanced Examination 2022, and this problem will be based on the chapter Chemical Bonding and Molecular Structure. Let's see what is the problem. Problem is list 1 contains metal species and list 2 contains their properties. And you can see some metal species are given in list 1 and list 2 are actually presenting their some properties. Right now, given atomic number of chromium, ruthenium and iron are 24, 44 and 26. Now match each metal species in list 1 with their properties in list 2 and choose the correct options. Some options are given. Now these are the metal species. Now in the next slide we will solve one by one with their properties. Now the first metal species is given as chromium CN6 4-. This is the given metal species in the first one of the list. Okay. Now oxidation number of chromium in this metal is +2, and the electronic configuration will give you argon 3d4 4s0. Now if you draw them or fill the orbitals, it will look like this. This is your 3d orbital, 4s, 4p and 4d. So 3d orbitals will have 4 electrons, right? 4s will remain empty, and the Cn are attached in the following manner. There are 6 Cn molecules in this complex which are attached in this way, right? So now the hybridization state of the metal in this species is sp3d2. That represents that this is inner sphere complex, because of the fact that Cn- is a strong ligand. So this belongs to inner sphere complex category because Cn- is a strong ligand, right? Now we will fill the Eg and T2G orbitals. So Eg will remain empty and our T2G will contain 4 electrons, right? So we can say that this is low spin complex ion. Low spin complex ion. If you check the property, it will match for R, right? That is low. The property R is representing for low spin complex ion. So it is matching with R. And now let's see what else we can do for this. So from here we can see also that this is a D4 species. because d orbital contains here 4 electrons. Also our T2G is having 4 electrons, right? So D4 species, which is also reflecting the property which is represented in T, right? So if you also consider the other properties, you can say that mu is equal to 2.8 bm. That is, it is having 2 unpaired electrons. Right? So for the complex, you can write that this complex is having the properties which are presented in R and in T, RT, right? Now let's solve for complex 2, which is Ru Cl6 2 minus, right? So oxidation number of Ru here is +4 and the electronic configuration is krypton 3d4 4s0. Okay, so it represents sp3d2 hybridization state of Ru. Of the central atom, that is Ru, central metal atom, that is ruthenium, right? Now, if you feel the Eg and T2G orbitals, this is for Eg and this is for T2G. So it will have 4 electrons in the T2G orbitals. So it will form low spin complexes. Also, this is a D4 species because it is having 4 electrons. So D4 species. Which indicates that T2G contains 4 electrons. And this is nothing but our P, which is the property given as P in the list as I have shown in the previous slide. And now if you consider for mu, it will give you 2.8 bm, which is representing that it contains 2 unpaired electrons. So we have property similar to T and P. So for 2, we can write, and also maybe not T because it is actually ruthenium is in the +4 oxidation state, which is represented here. This is similarly this is having similarity with the property which is given in S, right? So for 2, complex 2, we can write that it is matching the properties presented in P and S. So now you have to keep that in mind, or maybe after crossing this, I will write down again, that is I is similar to RT, the properties which are presented in R and T, and 2 is showing P properties which are presented in T and S. Now let's cross this and let's move on with the other 2 complex ions, right? So to keep the things clear, we can write that the complex ion I was matching with the properties presented in R and T, and for 2 was matching with the properties presented in P and S. So this has to be kept in mind so that we can match or we can choose the correct option from the final one, right? Now for the third ion, complex ion, that is CrH2O whole 6 2 plus. Here our H2O is weak field ligand. So oxidation number of chromium here is +2, and the electronic configuration is argon 3d4 4s0. Here your d orbital is containing 4 electrons, so it can be called as d4 species, which is again similar to the property presented in T, right? Now, if you write down the electronic configuration, you can write for the D4 4 unpaired electrons or 4 electrons in d orbitals. This is for 3d, and 4s will look like this, empty. 4p will also remain empty, and 4d will also remain empty. So it is presenting sp3d2 hybridization state of the central metal ion, that is chromium in this case. And also represents outer sphere complex, because our water is weak field ligand in this complex ion. And this is also high spin complex because Eg is having 1 electron and our T2G is having 3 unpaired electrons in T2G and 1 unpaired electrons in Eg, so it represents high spin complex. This is also a D4 species because your T2G contains 3 electrons, and so your mu is equal to 4.9 bm. This is because there are 4 unpaired electrons, right? So this property is similar to what is given in the option or Q in the list. So this is giving you the options for the complex ion 3 as Q and T. So if you write down here your option or the matching list for the complex ion 3 is for Q and T, which are given in the table, right? Now we will move for the final one, that is FeH2O whole 6 2 plus, right? This is the complex ion which has been given in the number 4. Here oxidation number of Fe is +2 and the electronic configuration, if you check, it is argon 3d6 4s0. Now if you fill up the orbitals, you will get for 3d you will have 6 electrons like this, and the rest of the orbitals will remain empty, that is 4p, 4s, 4p and 4d. They will remain empty. Now also it represents sp3 d2 hybridization state and also outer sphere complex. Outer sphere as well as high spin complex. So from here you can see that it is a D6 species. So you can write D6 species because T2G contains four electrons, and we will now draw so because T2G contains 4 electrons, it is matching the property which is given in P, right? So our first matching is for P, and now we will draw the EG and T2G orbitals here. So our EG, so I will go to here to finish it up. So your EG will have 2 electrons because it is a D6 one, so EG will contain 2 electrons each, and your nu is also, let's draw a boundary so that it will be clear for the final one. So mu is again here 4.9 bm because 4 unpaired electrons are there, 1, 2, 3, 4. So EG looks like that, and now let's see how T2G will look like. So for T2G will look like right? So 4 electrons in T2G orbitals. So it will match with Q and P. So the last one is, that is our complex ion 4. It is matching with P and Q. As given here, mu is 4.9 bm and T2G is having 4 electrons. That is, this is actually matching the property which is presented as P. So one is matching with R and T, complex ion 2 is matching with P and S, complex ion 3 is matching with Q and T, and complex ion 4 is matching with P and Q. That's the way you should solve. And now if you go back to the question, you can see that our option A is the correct option. So you have to choose the option A for the answer of this question. So I hope you have enjoyed. So for more such problems, you need to visit our website. So keep visiting aptdemy. Thank you very much. Have a good day. Thank you.